Hello, Math 126 fans. This is Dr. Andy Love. So I'm going to talk about test prep that was on 12.2, 12.3, and 12.4. These were vector facts. I put a lot of questions on this test prep because there are so many small things in these sections. So I thought it would be helpful to see quite a collection of old exams. I do want to note, at any point, if you're looking for resources, for example, I handed out a review sheet. I have someone asking on the discussion board, how do I find those review sheets? You're going to find any review sheets I hand out on this materials page. There's the exam archive. I believe the thing I handed out was the chapter 12 fact sheet. There are links to this in the materials as well. This is just sort of a recap of, do I understand what's going on? And then the old exams are here. And this is something I'd always be doing. It's just, if you're sitting there before or after class, open up an exam and say, how would I start that question? How would I start this question? And I'm just trying to help you with that by building it into your schedule with these test preps. Okay, so this one it would take a long time for me to go through every problem in excruciating detail, but I hope to say a little bit about each one, and then hopefully you can follow up with me by asking questions on the discussion board or coming to office hours. Okay, so the first question was this. So you do want to play this game of, if this was on a test, what would be my initial reaction? And if your initial reaction is to look on a note sheet, then that's no good. You want to be able to get to a point where each question you have an idea about how to start. And as you're studying, you want to think, okay, I didn't have an idea of how to start that one. Find the angle at A, or another way to say it is find this. Now, that's a question from the homework. So I always hope that students who have seen a homework question would have a plan of attack. And what this means, if you didn't catch this when you were doing the homework, is it means you're trying to find this angle. And we have a big, useful tool for finding angles. So the moment you see find an angle of something, you should start thinking about our 10-star fact. So to me, this problem sits nicely in the things we know. But in order to use the 10-star fact, that's mostly what the question is about. Do you understand how to use this? The vectors have to be tail to tail. So the most important part about this problem is knowing that you need these two vectors. So one of your vectors needs to be AB in that order, and one of your vectors needs to be AC in that order. And that's what this question was all about. There's a lot of things like this. If you don't understand the order and how it matters, a good rule of thumb is wherever you're going from, wherever you're coming out of A, wherever you're emanating from, that's the thing you're subtracting. That's the tail. So you can quickly do a visual check of the tail should be here when you do your subtraction to get your vectors. So if you don't have the same thing being subtracted each time, something's going wrong. Okay, so now we're going to put B here. 1, 1, 3, negative 1, 2, 4. So this is what I mean. This should be a fast question on a test, but I find some students take a long time because they're spending so much time looking on their note sheet. We've got to get a little past that. At this moment, we're done. We plug that in here. We take a dot product. We do the magnitude. We do inverse cosine. I think I'm not going to show all that. I'll just pull up my solutions. You can see and you can see the solutions. I have them posted on my materials page, but I wanted to talk about process. I computed, I hit the inverse cosine. It is good to practice calculation. I remember on this exam, a few students calculated wrong. They hit their calculator buttons wrong, and that's something that you've been practicing on the homework. That was a small deduction. But I hope you can look at that question and say, okay, it's about an angle, 10-star fact. I need to find the two vectors and do it in the right order. Boom. You did it several times in the homework. You did it here. You don't want to be surprised on the test. All right, let's try another one. So the next one is actually another homework question. So again, if you saw this on a test, I put this on an old test in fall 2013, you wouldn't want to be shocked by it. And this was really about, and there's students were talking about many different ways when we did this in class, but it's about adding things together. Now, I remember students that quarter being mad. They're like, what do you mean resultant force? That was directly from a homework. This was in the homework, that word. I would never give you a word that you hadn't seen in the homework or that didn't coincide with things I emphasized in class. So I didn't put this word in there to confuse students, but that's just to give you an example of that quarter. Students told me that wording was confusing. Some students came in and were really mad at me about it. And so I had to show them the homework question. It was unpleasant. This is where you can help yourself by practicing old exams and saying, would I have been surprised by that? Would I have known what to do? If you're just looking at my solutions, you're like, okay, I get it. And then you're going to be in that same situation that those students were in, which is they were distracted by something in the problem. Okay, so anyways, this is about, can you find the vectors A and B? If you don't remember how you did that problem, you would add this to your note sheet. The vector B can be described as negative 100, 0. Again, these are the lengths. That was this question where I told you the length of this vector and it's pointing this way. I told you the length of this vector, and we do a little bit of trig. What we really want is the x and y coordinates that make that happen. Okay, so we do a little bit of work here. If you've completely forgotten how to get these values, you could play a little trig game. You could say, well, cosine of 60 is, and this is just good to know in general, is the change in x over 80. So I need to do 80 cosine of 60. So you say, well, I don't know cosine of 60. You'd put that on your note sheet. This is stuff that, by looking at old tests, these are things you go, okay, I better put that on my note sheet. You might ask. Cosine of 60 is a half. And then same thing, 80 times sine of 60, square root of 3 over 2. Note that I can tell that this point is going to have a bigger y coordinate. So there are many ways for me to see that. This is going to be 40. This is 40 root 3. That makes sense to me in the picture. The rest of the question is to add those together. A plus B is equal to negative 60, 40 square root of 3. And then we switch gears. The last part of the question is saying, okay, now that you have this vector that points over here, can you tell me this angle? And I mentioned in class that in my opinion, and I remember a lot of students drew a triangle and got the correct answer, took a few extra steps, but I mentioned how the direct way is if you know the length and you know something about the x and y, then you can use the same relationship we just used. So cosine of that theta is whatever the x is divided by whatever the r is. In this case, the r is the length. So theta is inverse cosine of whatever the x is, which is negative 60 for my vector, divided by whatever the length is, which is the square root of this mess. 60 squared plus 40 root 3 squared. I suspect that's what I did in my solutions. Let's go look and see. Let's pull them over here. Yes, that's what I did. And I got that it was 131 degrees. Okay, let's leave that and move on to something else. That was the 2D vector fact stuff. Okay, so then we have this rescaling question. This is a question from 12.2. If you're wondering where the one up above came from, it also came from 12.2. Okay, find a vector that has length 4 and is parallel to the tangent line here. So the moment you see the word tangent line, you should be thinking derivative in any calculus course. And they're talking about when x is 3 and y is 13. So it would be nice to know what the slope is when x is 3. And we can do that. Y prime is equal to 4 minus, that would be 6, equals negative 2. So I want a vector that has slope negative 2. We talked in class about how there are many that do that. But in particular, I could use 1, negative 2. Do I have to use a 1 here? No. But whatever you put there, the next one's going to be negative 2 times that. Okay, the problem with that vector is it does not have length 4. In fact, you could find the length of it. It's going to be the square root of 1 squared plus negative 2 squared. It's going to be the square root of 5. That unfortunately is not 4. If you multiply this vector times 4, it also won't be length 4. It'll be 4 times longer. So that doesn't work either. So we learned a little technique, which is to make it a unit vector and then multiply by the desired length. So if you forgot that, that's what we're going to do. We're going to make a unit vector, and then we're going to multiply times 4. So in this case, it's going to be 4 over root 5 times 1 negative 2. Success. So that was that rescaling idea. Find the length of the projection of acceleration in this direction. So when I see that, I'm like, hooray, I have an immediate answer. It's like, so I think the language of the problem throws people off. But the moment you see it's a projection, we have a formula. You take the dot product of the two vectors and you divide by the length of the thing you're projecting onto. Now, honestly, I didn't realize, I remember when I gave this question that a lot of students were confused by this. It was not my intention. I know now why they were confused. I think if I had not asked part A, more people would have got it right, which is one of these surprising things. Because you could just project, it would be the exact same thing if you projected A onto the vector 1, negative 2. In fact, that would be easier because you could just do A is 0, negative 9.5. And this is what confused people. The length from the previous part seemed to confuse people. So this would have been easier because I think that the fact that there was that 4 threw people off. It doesn't matter if you use this vector or a vector that's longer. The projection is going to be the same. The length of this is going to be the same. And so this would be whatever that is. 19.6 divided by root 5. Done. You can also use the vector we had here. Now the vector we have here at this point, if we're going to use it, we probably want to expand out. Negative 8 root 5. And then we can do the dot product of these two things. So we're going to do negative 9.8 times negative 8 over root 5 divided by the length of this vector. Now the length of this vector is 4 over root 5. 4 over root 5. So I remember that a lot of students got there and like, boy, this is confusing. But the root 5s cancel. The 8 over 4 becomes a 2. Oops. I made the mistake. I think I won't even edit that out. So that's why the students made the mistake. The length of V is 4. I made the mistake the students made. Oh, man. I would have caught that in a second, I think. I was channeling the errors that I saw. Because the length of it was 4, not 4 over root 5. Either way, we got the same thing. That was this length here. Okay, that's the solutions. Great. Next. So then we got another rescaling question, but also an orthogonal question. So this is actually 12.4 and 12.2, a little bit of both. The moment you see orthogonal to both, you're going to do a cross product. Hopefully you're getting really fast at that. We've now done this quite a bit. I, J, K, here, and you do this game. And you have a way to check your work. There we go. And you go 0, negative 4. And you want to take every opportunity to practice this. Negative 2, 0. You also want to practice the moment where you check your work. Is this perpendicular to this? Yes, because it's 4 plus minus 4. Great. Is this perpendicular to this? 12 minus 10 minus 2, 0. Success. Now we're going to rescale it to length 7. We know how to do that. We do 7 times the length of the vector times the vector. So we're almost done. So we need to get to where we start to get a rhythm of most questions we know how to start. If we're looking something up on every single question, we're in trouble. Okay, then another projection question. It asks for this length. That's a direct projection question. I think there were labels on these other things. They must have gotten cut off. Let's call this C and let's call this D. We're doing the projection of AC onto AD. And I'm happy the moment I realize it's a projection. I need those vectors first. So you'd have to find AC. Let's just write it down. AC is 3, 0, 2. How did I get that so quick? I did 3 subtractions. We're projecting that onto AD. What is AD? 2, 1, negative 2. And then you divide by the length of the thing you're projecting onto. Square root of 4 plus 1 plus 4. So it ends up being 6 plus 0 minus 4 over 3. 2 over 3. This is what's nice about projections, is how quick it makes problems like that. Okay. Last one here. Find the vector obtained by projecting U onto V. Okay, so that's a direct. Let me talk through the process here. The component projection just tells me the number, but that's all you really need to know. I'll explain why in a second. This brings together several things from this. So let's project U onto V. So it's going to be 6 plus 2 plus 0 divided by the length of V, which is the square root of 4 plus, so square root of 5. So this is 8 square root of 5. I don't ever even remember the other formula. I just think through how to get it. What do we want? We want a vector in the direction of U. Here's what's happening in my head. I've got U onto V. Sorry, a vector in the direction of V. It's good I drew that picture. But I want it to be this long. So I want this vector. That's going to be rescaling of V. So we get to do rescaling, which we've already done twice in this test prep. We're going to take the vector V, we're going to divide by its length, and then we're going to multiply by the desired length. So it's going to be 8 root 5, 1 over root 5 V. So it's going to be 8/5 times V, 2 negative 1, 0. Done. Yep. Okay. Just making sure. And then the area of the triangle with these corners, that's a cross product question. That's a 12-4 question. So whatever you're going to label these vectors A, B, C, you should know, here's what you're going to do. You're going to do AB, you're going to do AC, you're going to take their cross product. When you're done, you're going to have a vector, and you want the length of that vector, and then you want to divide by 2. So ultimately this question is this question. You're going to do cross product, find its length, and divide by 2. So I encourage you to try that out. It's mostly practice with a cross product. There we go. So there's a little recap. We did several vector things there, a mixture of things from 12.1, 12.2, 12.3, and 12.4. I hope that was helpful.